Now it should be correct. Sorry about that. I think I was confused with the other terminal that I had. So basically, yeah. Now I think you can see things some like when I type.
Yes, we can see now.
This screen, right? Yeah. Okay.
Yes.
So sorry about the disturbance. So now you see this the setup Questa is by gcc.sh, and then like this is the first few parameters are there to set up the Questa license. This is needed for you to run the vSIM, and then the rest of the things are as per the pulp documentation. Basically, this is how you need to set the GCC toolchain and then the vSIM paths once you build the simulator model. So we can basically environmental variables are set for us, right? And then once you set up that one, basically I will again go and show you how you can like run a simulator model simply. If we move to the Pulp SDK, Pulp SDK and try to run a simple example. We can run first. We have to source the board configuration, and then we'll move to the example. Okay. This time, like I will set platform RTL so that it will run on the simulator. This time I'm for the first time I'm running on the terminal itself, so no GUI is being used just to run the simulation. Okay, so you can see that in the std out, it has printed hello from MC. This is what you get. Like even if you run the GV soft emulator, if you can remember, we did that last time. You get the hello print. This is all what it does for this small program. And at the same time, we can see now. I think today's main focus is on the how to use the Questa simulator GUI mode, where Raghavendra will explain more about how to use the Questa simulation. So I will next get into get into the GUI desktop using the VNC Weaver, and then we'll see how GUI could be opened for this to run the same thing, and then uh, we can go over that more with Raghavendra regarding like how to use the Questa sim and so on. So in this case, I have already started the VNC server in the using my SSH terminal already, so that's why I didn't type it again. So basically, if you check my history, so I have used this command already to start the VNC server, and then I can connect it. And then I already have forwarded the 5901 port to localhost. of my local machine so that I can open it simply using local host 5901. And oh, we can enter the password you have provided. I think just like DVCon. I think I have provided in the document the password which you need to log in, and then you will see this UI desktop. And similarly, similar to the other SSH terminal, here also you can open the terminal and go to DVCon first and source setup, and then go to Pulp SDK. Let's source the port configuration first. And then what you can do is go to the same example and run it. Since I have already built it, I don't need to make clean and all. I will just make running, but this time and set the platform anyway to RTL. And this time I will set the GUI option to let me expand this a bit more. I will set GUI option to 1 so that the simulation will open in the GUI instead of the terminal. Now from here, like from the now you can see the Questa sim GUI has been opened. Basically, what happened? I think I messed up with the format. Sorry, I think I just accidentally messed up with the window view. But just to you can what I wanted to mention is like you can see the same simulation log you can see in this the transcript window of the simulator GUI as well. So basically now from here you can select Raghavendra, like basically how you can reset the setup to its
there is a
original,
layout. Click on the layout. There is a reset.
Yeah. We can reset. Sorry, I'm also not familiar with that. Okay, this is nice. So yeah, basically you can see it from here. Now since I have already done this one previous time also, basically using the TB pulp, you can find out this one in the like pulpissimo directory. There is a RTL directory, and on the RTL you have TB directory where all the test benches related files are there. So the TB pulp.sv is the test bench top module, and this is what you can see in the simulator as well. This is the top module of the test bench. And from there, the device and like the DUT or device under test is the this time. So you can basically figure out this information like you need to get into the pulp sock through that one through the sock domain, and then on the FC subsystem you will find out the core. So basically I just want to show you like how things come after the core. From there, let's say we can just try to print some like view some signals, let's say clock
Upal,
reset,
I think
and
I'll take care of maybe that showing that path.
now this is fine, right? You can continue
Yeah,
from there itself.
yeah.
I just want to show these signals. Yeah, so maybe
Sure.
some instruction and data signals should be nice to have. May I add some of these to the waveform?
Sure. Go ahead, please. Yes.
Yeah. So from there onwards, I think it's the Raghavendra is the best person to show what you can do using this GUI. Yeah. So are you going to open the same like the GUI from?
I have something else actually. I'll open this as well.
Problem.
So I have one which I've opened already for my own case, but I'll open this as well. So not a problem.
Okay,
I can show you the signal.
Yeah, maybe now you can share yourself, right?
Sure. I'll do that. I hope you can see the screen. You can view this. You can see the screen.
Now, okay. Yes.
Okay.
Now we can see.
Okay, so I have the Ubuntu VNC which Upal was showing as well here, and also for the ease of use, I've opened one with my own database which I had. I'll go over the database which I have here to show, because I have enabled a lot more features which is not enabled there. So I just thought of enabling here and then showing it for the ease of use. But you can use it here as well. I'll show you the files which needs to be updated, and then you can go over it. So if you want to change anything and add something. So I think Upal did mention that. So once you run this files, right? So there is a tickle command. So all these are tickle-based commands which has to be opened. So here there is a file called vsim_tickle which gets sourced when the make option is run. So basically there are three kinds of commands which is getting run. One is the vlog command, which is used for the compilation. And then one is the vopt command, which is used for the optimization of the design. I'll tell you what is optimization compilation as well. And then one other is vsim. So there are three options which is getting run. These three commands basically which is getting run. So all of them you can edit. So there are a few options which is already then added, pre-added. So if you want to edit it, you can open the tickle file corresponding to that. There is a compile.tickle file. There is a vsim.tickle file. There is one more called RTL_vopt_tickle file. So there are three files which is relevant for them, those commands. You can open them, and then when you see there are options which says, okay, this you can enable, and then you can run it. So by default, few options are added. Say like for vopt, we add the assertion debug. We add FSM debug. So if you have any FSMs inside your RTL, so debug that, you can add these options. Similarly, for vsim, there are a few options which has to be added. So like say you want to open up in the GUI mode, so you don't have to add -c, which is a command prompt options. And then so if you want to try enable the coverage part, you have to add -coverage for the. I'll give this option. Maybe I can give it in a separate file or something which I can share where you can look at it as well. I'll show you. And then once you run it, the GUI will open something similar to this. Okay, probably I'll go back to the same GUI which is there open for my environment. So there are windows like this. Once you open up the GUI, to the left side of your GUI window, you will see the hierarchy which was mentioned earlier. So you can see the top, and then that is your test bench, and then the .dat instantiated inside it. So once I click, if you can see that the objects related to those the top modules are populated in the objects window. There's a window called objects window, where once you click the hierarchy the objects related to those are getting populated. So when I say objects, that's the input output ports, the parameters, the reg declarations, logic declarations, arrays, all of that, which is present for that DVT. By chance, if you don't see this, so you can just go to view and select the object window here. So and then that gets loaded here. And then you can select. So these are all clickable. So you just click and select. To select multiples, you can hold the control button and then select it. And then right click. It will show you an option called add wave. So once you do this, those signals are getting added to the wave window here. Okay. So this gets added. So you can maximize it. You can this zoom in, zoom out. You can do fit to the screen. You can do all of that. You can do here. So okay, those things you can take care here in the window. Again, coming back to the GUI. So say like you want to see the source code of it. Say you have your duty and you want to see what is that which is written inside your duty, right? So you can double click. The source window opens here to the right side. You can see here. Scroll up and see what is that you are written inside the tag. Okay, and then I think you can do breakpoint. Say like if you want to debug till this point, and then continue debug after that. So you can put a breakpoint and then say run until here. So that means that you are putting a stop condition here and running the simulation till there, and then breaking the simulation to debug it from there. Okay, those things you can do it here. Okay, and then there is a window called library window. So there are some default libraries which gets loaded when you open this GUI, and also a work library which is getting created when you compile your design. So by default, the work library gets created. So all your compiled files are sitting here inside this work folder. You can change it. By default, it comes under here as a work folder. And if there is any memory, there is a list of memory shown here. So you can add the memory and debug it. Similar to that, you can see the files. Say like you want to see what files are getting added in my submission. Basically, the compile list that you can see it here, and then path of that file will be listed here. Okay, the files. Again, there is a Control F option here. So if you want to search something, you can just type Control F and search the file relevant to you. This is same with all the other window as well. So if you want to do Control F here as well, you can just do the Control F and search the particular hierarchy, and it will take you to that hierarchy, and then you can start debugging. Okay. So this is about the windows which is present here. By default, there will be a transcript window here, which is shown below, which I think Upal mentioned it as well earlier. So whatever you run is listed here. So in my case here, I've run a UVM design, so it has shown me certain info about the UVM messages. Similarly, in your design, whatever you run, those messages will be listed here. Okay, so this is saved into a transcript file, so that you can open in the GVM or VIM, and then you can see there as well. Okay, so you can open, double click, multiple files gets opened side by side. You can click on them and then start debugging whatever you want to debug. Okay, so you want to see the schematic. Say like you want to see the schematic of the DUT, how the structure looks. You can just right click, view schematic. Schematic you can do, and then you can see it here. Okay, double click it. It will take you to the connectivity of the signal, and then similarly there is one more window called data flow window, where if you want to have particular signal and see how the connectivity of the signal goes inside your debugging. When you're debugging, maybe you want to see what is that signal connected to, how is it connected to. There is a window called data flow. So again, you can add to data flow window. It will show you that, okay, there is a connectivity which is happening to that, and you can double click it again on this, and then it will take you to the connectivity port. You can continue debugging like that in the data flow window as well. Okay. Say if you have your FSMs, you want to debug those FSM and you want to see the state machines, how it is. So that can be also done. Say like you want to see the FSM list window. So there is a FSM list window. You click on that. And then if you have FSMs inside your RTL, those will be listed here. So say like you want to debug one of them and see how does it look and what are the state changes happening. So just double click on that. There is a FSM window which pops up to the right side of it, and you can view the state. You can view the state, you can see the conditions, and then if you want to go back to the source window where this is happening, you can just double click and it will take you to the source window. View declaration. Okay. So, and then it will take you to the declaration of what state is that here. In my case, it is this, and then it is showing there where that declaration happened. Okay. From there as well, you can debug. So, and if there is an FSM stuck, then you can put a breakpoint here and then run until there and then start debugging from there. Possible. Okay. And then again, objects window, I showed the objects window. That is the window which is here, which is coming. And files I showed. Coverage, I think if I have not enabled coverage here, but if you want to enable coverage, you can add few options like plus cover into the vopt and vsim command. I'll show where to add it. So once you add that, that coverage will be enabled and you can start debugging using coverage analysis window. Here, once you add it, you can just go to the hierarchy what you want to debug, and then there will be a coverage enabled for that. You can see the numbers here, and then you can start debugging from there. Okay. So I was talking about the documents. So documents, see here, there is a help. So once you click on the HTML window document, there is the HTML window opens up. And it will ask you, there are two files which you can view. One is the user guide, which tells about the usage of it. So how the Questa sim can be used, how the design library can be created. So there are lots of sections which you can view in advanced debug. All of that is there present in this. So you can go to relevant sections which you want to understand, and then you can go ahead and implement that inside the GUI. Similarly, there is a reference guide which can be viewed for adding the options. So there are all these options which we added by default, right? So if you want to add more options, I told there are three commands, which is log, vlog, vopt, and vsim commands. So if you want to add options to those commands, you can see the relevant options here and then keep adding those options and you can run it, which I showed here as the tickle files. Okay. There is a GUI reference guide as well, so which you can view it. GUI reference guide. So here it tells what are the different windows which is present inside the GUI, which I just showed. Okay, for assertion debug, there is an ATV window. There is a coverage window, which I showed. Similarly, there are lots of other windows which is present. For waveform, you want to put another cursor, all of that can be done. So a lot of options present here. You can just click on some of them, whichever is relevant to you for debug, and then start debugging from there. Okay. So going back to the environment which I had here. So this is the environment which was so the pulp environment which Upal was talking about. Even here, if you see, I've run the example. The same thing can be done here. So If I want to add the DVT core, well, you mentioned
Yeah,
that,
so
right?
I think in the SOC domain,
In the SOC
that
domain,
one, SOC domain, then
well,
we have
SOC.
SOC, and below there should be something called FC subsystem, FC underscore subsystem.
FC underscore.
Yeah, you can. You should.
Yes.
Yeah, this one. Sorry.
Okay, inside that, this one, or inside that, anything else specific? Which
inside that, this is one FC core. Yeah.
Okay. So if I have this here,
you can add some signals, inputs and outputs.
I think I can add the clock reset thing, which is bare minimum thing, and then your address. Similarly, I can add it to the wave. Okay. To the wave. So if I want to restart that, I can just restart. And everything gets loaded from start. And then you can see the same signals loaded here. Okay. I want to run for some time. I just back here. Okay. The simulation runs till that time and it halts because I've given the time unit till what time it has to run. Okay, I can pop out this window. It comes out like this. Okay, I can see the fit screen. So that means simulation is running. It stopped that time. Okay, till what time I want to run. So the view window looks like this. You can click on the signal and see the value of that at that particular time. Anything like zoom in, zoom out can be done. So I'm using the control button, then selecting between two, some time unit, and then expanding it for debugging. Okay, that I can do. And then to fit back, I can click on this. And then, so if I want to put a marker here, so basically a cursor again, I can just click and then create a new cursor and then keep moving that here. So I have multiple cursors now for debugging. Fit screen. So I can just take one of them to anywhere else and then keep it. This will help me to debug if there are multiple signals which you are debugging at a time. Okay. There are a lot of other options. I think I would like you guys to go explore it, like calculating the frequency, all of that can be done. Grouping of the signals can be done if you have an array here and you want to group only few of them. So all of them can be grouped and kept it into separate file. So a separate signal, and you can create it and then you can start debugging. So you can select each of them and then right click and group it. So that you can do it. Combine signals you can do. If you want to force a signal at the runtime, you can force that signal. All of that can be done. Just right click it and then you'll see all the options which is listed, which you can do it for that. Okay. So again, I think as I told, the source code is open here. You can start debugging. You can click and the objects window populates through it. Multiple signals can be selected. You can add it to a list window just in case if you want to have a what do you call it? So you want to see the thing selected signals to the list window. You can just put it to the list window and you can keep a watch on what value it is coming when the simulation changes. So there's multiple selections you can do. That means like you go to a different hierarchy and then you want to add it to the list window, you can still add that. that will come up here and then see the value of that signal when you add it to the list window. Okay. So you can just keep a watch on the multiple signals which you want to do while the simulation is running. Okay. I think once you do, there will be option cases that there will be multiple windows getting popped up. So you want to reset it like we did earlier. So just reset it. It will go back to the old setup which we had it. So that means the way window comes here, you can just pop out of this windows. Any window can be popped out and then popped back if you don't, if you want to debug it better. So and then all of them are dragging here, can drag it like this and then make it expand and then smaller. Okay. Here again, there are options like simulation, start simulation, run until sometime, run next, all of that you can do. These are also clickable. As I showed also in the source window, you can go and click. That is possible. Okay.
Raghavendra, like a small thing now, like when you are in a complex design like this, so there may be hierarchies like we need to find out a lot of hierarchies like this. There is a module which has to go very deep inside and find out some waves. Say now you need to close this simulation and restart it again. I mean, somehow if you are in the same window, that is fine, so that that setup will be kept. But if you close this one and start it back again, is there any way that we can load to the same configuration? I mean, the say I have already added a few signals to the wave window. Is there a way that I can save that configuration and load from there?
Yeah, you can do that.
I think that will be very useful if you just
yeah. So you have a list of signals which is already here. Say like you want to save the signal into a file and load it to the next time when you want to do it, right? So I can save it. So it saves me to a do file. You can select where you want to save it and click on OK. So what it does is it saves the signals which you have added here in the wave window. So next time when you pop up the wave, like say now I have this wave. I close this wave. Okay. And then I want to open a wave window again. This is for the next time in the run. Here I can go load that wave.
Yeah, that.
Yeah, so once I load it, the GUI window which is already present, I mean this GUI window will be opened up, but the wave window which you have opened, which had nothing, it will open up all the signals which you have saved it earlier. So that way you can just get all the signals instead of just going again to the hierarchies, all of that, and then you can just load it there.
Yeah.
So straight away you can do that. Yeah, that is possible. Anything else specific, Utpal? Do you think which I should? I think this is all I had.
Yeah, so as a user, like I was looking at from user's perspective, so this is one important thing that I have come up with. Other than that, I think most of the things you have already shown. So we can take some questions from the competitors audience if they have any.
Anyone, any questions or how to do anything of that sort? As I shown, there are documents which is available, so you can just click on them and then open them. You can also open them in the PDF format if you want to, and then search for them and then look at the options. There are different things which is present, how to do, what are the options, all of them are given here. So I would like you guys to explore it, try it out, and then see. Okay. Okay, any questions? Okay. I think, Pradeep, that's all I had.
Thank you, Raghavendra,
Thanks, Sarah.
and thanks, Upal. If
Okay.
you have no other questions, then probably we can conclude this meeting. In case if you have anything more, please feel free to send us the mails, and we will try to respond as early as possible. And also, please remember 31st August is the last date for submission of this.
Yeah, and basically, yeah, you have 1 full month, but with you have to manage yourself with all other work that you do in the universities and all. But with that one, this because like it's not a trivial task. So basically, when you start early, you will get more issues on the way, so that you can raise with us, and then we can also help. If you have if you have raised the issues earlier, we would be able to go through them and try to help you out. But if you wait until the last moment, it will be hard for us to iterate back and forth. So start early, try to use your free times, and this will be a very interesting project that you need to try out. But my advice is start early and utilize this opportunity. Yeah, thanks.
Yeah, thank you all.
Thank you. Thanks,
Yeah,
Sarah.
so then I think Raghavendra will share the recordings with Seru, and then Seru can share with the team. So you can refer this will be very important, I think, to refer back to it, whatever the things that especially Raghavendra did during the you can refer it back, and as we mentioned, you can ask any questions anytime through our email areas. Yeah.
All
Sure.
right. Yeah,
Thank you.
thank you all.